Welcome back to Study Studio. The new topic, path length. It is the length of curve joining the initial position and final position along which the particle has actually moved. Acceleration. The rate of change of velocity is called acceleration. Its SI unit is meter per second square and it is a vector quantity. Formula for finding acceleration is A is equal to V minus U by T, where V is equal to final velocity and U is equal to initial velocity divided by time. Types of acceleration. There are mainly two types of acceleration. Number first, uniform acceleration, and number second, non-uniform acceleration. Uniform acceleration. If an object travels in a straight line and its velocity increases or decreases by equal amounts in equal intervals of time, then the object is said to be in uniform acceleration or uniform acceleratory motion. Example, the motion of a freely falling object, the motion of a ball rolling down on an inclined plane. Non-uniform acceleration. If an object travels in a straight line and its velocity increases or decreases by unequal amounts in equal intervals of time, then the object is said to be in non-uniform motion or non-uniform acceleratory motion. The motion of a car on a crowded city, the motion of a train leaving or entering the platform are all examples of non-uniform acceleratory motion. Uniform and non-uniform motion. Uniform motion. If an object travels equal distance in equal intervals of time, then it is said to be in uniform motion. Number 2. Non-uniform motion. If an object travels unequal distances in equal intervals of time, then it is said to be in non-uniform motion. Graphical representation of motion. Distance time graph. Distance time graph represents change in distance with respect to time. In distance time graph, distance traveled is taken along y-axis and time taken to travel this distance is taken along x-axis. The distance time graph for uniform motion is a straight line, and the distance time graph for non-uniform motion is a curved line. Question: what quantity the slope of distance time graph represents? Answer is that the slope of distance time graph represents the speed of an object. Distance time graph for stationary objects is a straight line parallel to time axis. Number 2. Velocity time graph. Velocity time graph represents change in velocity with respect to time. In this graph, velocity is taken along y-axis and time taken along x-axis. The velocity time graph for uniform acceleratory motion is a straight line. Velocity time graph for non-uniform acceleratory motion is a curved line. Velocity time graph for constant velocity or zero acceleration is a line parallel to time axis. Equations of motion. The equations which establish a relationship between velocity, acceleration, the distance traveled by the body are known as equations of motion. First equation, V is equal to U plus 8t. Second equation, S is equal to ut plus 1 by 2at square. And third equation, V square is equal to U square plus 2as. U is equal to initial velocity, V is equal to final velocity, S is equal to distance traveled, and T is equal to time taken, and A is equal to acceleration. Question: what quantity the slope of a velocity time graph represents? Answer: the slope of a velocity time graph represents the acceleration of the object. Uniform circular motion. When an object travels on a circular path with constant speed, then it is said to be in uniform circular motion. When an object is in circular path, then its velocity continuously changes to every point. Question: give example for an object traveling with constant speed but varying changing velocity. Answer: an object is in uniform circular motion, moves with a constant speed. but with varying velocity because its direction is continuously changed at every point. Rectilinear motion. If an object travels in a straight line, then it is said to be in rectilinear motion. Number 2. Oscillatory motion. If an object moves to and fro about a fixed point, then it is said to be in oscillatory motion. Example, motion of a simple pendulum. Unit conversion of for speed. Kilometer per hour to meter per second, we have to multiply it by 5 by 18. For converting meter per second to kilometer per hour, we have to multiply it by 18 divided by 5. Thanks for watching my video. Please like and share my video and subscribe my channel.